Okay, so we'll discuss Kubernetes volumes today. So we'll go through the concepts and some examples. So I have not tried examples beforehand, so I will try along in this session itself. Uh, so what is volume and why is it needed? So if you see in a pod, there are containers. A pod can have one or more than one containers, and they share RAM, CPU, network interfaces, but they don't share the file system. Now, what might happen is when pod get crashed, container get crashed. They are temporary in nature. So anytime they crash, and then Kubernetes will start new container or the pod. They should, they would want to continue from where they had left. If they're storing something in the file system, this is majorly focused on that. So they would want to maintain, something in the file system, write something or read something from the file system, from some file in the file system. So basically, idea is that the files, wherever they're reading it from, it should get, reattached, or they should get access to that again once pod or container restart. It's a container, I'm sorry, it's not pod, it's container when container restarts. And the storage volume, the way to solve this problem is the storage volumes. So storage volumes life cycle is same as pods. So pods can come and, if pods gets deleted, storage volume is also, it's not deleted in reality, and we'll see in subsequent session, but that's also gone. You can't access it anymore. So it's so the storage volume life cycle is same as the life cycle of pods, but it spans the life cycle of containers. So if containers are getting crashed and they're restarting, so they will have the storage volume available to them. So all containers of a pod can use the same volume. And there are many various examples. Why would you want to do it? We'll discuss one example here, but you can think of, some configuration is written into some file system, and that we'll see in the config map also. Your two system, one is writing, one is reading, for example. One is writing to a file, one is reading from the file. So when you have such use cases, then use storage volumes. And all containers, as I said, all containers of a pod will use the same storage volume. So these are components of pod and defined in the pod spec, and they are not independent and cannot be created outside the pod. So so these are the few informations about volumes. And we have various volume types. Now, what are those volume types? We have these types which I'm showing on the slide. You have empty directory. So empty directory to store some transient data, and we'll see one use case of this. We'll have an example also. A host path. This is used for mounting directories from the workers file system to the pod. Like we do in even Docker also. If you're using only Docker, you can mount the host path as well. So something similar. Gitrepo, it is a volume initialized by checking out the contents of gitrepo. So you can have a Git repository attached as a volume, and whatever is in the Git repo, the content in the Git repo, that will become available in the volume. This Git repo is deprecated now. So it was the first class citizen earlier, but now it's deprecated. We have NFS. So NFS is a Linux, system. So so you have this NFS. You can have NFS share mounted on the ports also. Then there are various file systems. You have, Sinders, CFSs, ISC, FI, Flocker, Cluster FS, and all those things. I have not worked with many of these, honestly, but these can also be mounted on the ports. So as I will just just summarize what we discussed so far. Just one slide that in a pod you can have containers, and these containers can come and go. So you would want and a pod can have multiple containers. So you want to share data in these multiple containers via a volume or file system. And our second thing is, when this container, any of these containers can get crashed, and pod will bring the another container in place of the crash container. That container should get access to the same volume, because it might be reading data from the volume or writing to it or something like this. So for that, the solution is the volume. So volumes lifecycle is basically based on the pod. So when port goes away, volume also sort of goes away. And but when container goes away, volume is still there. So that when the new container comes up in its place, it can get access to same volume. And these are the volume types. So we were, so another is the config map, secret, and a downward API. So these are special volume types to expose certain Kubernetes sources and cluster info to pod. We'll see, in the subsequent section, some of these. We'll go through the config map and secret, of course. Downward API, I might touch upon it. I will not go into details of downward API, but we'll just touch upon it a little bit. There's a persistence volume claim. We will go through this today if possible. It's way to pre or dynamically store persistent storage. Now a pod can have multiple volume types mounted. So that's the concepts about volume types. Now we'll take an example of empty dir. So it's an initial empty directory, and generally you do when you use it when pods write into it. And as I said, its lifecycle is associated with pod. Once pod is deleted, then this is also deleted. So it can be used to share files between containers within a pod. So these containers are within a pod. So because it's empty, so one possible use case could be that one container writes, another container reads. So so that's why this is one place where you can use the empty dir. So I will go to that example, but let's see the what I am doing in that example, and then I will run that example here. So you will have so what we'll do in this example is we'll have one pod which will have two containers, and both containers will have access to the same empty dir. So it's the data volume mounted on both containers. So first container, it's a I have a sort of project called geocoder. So in that project, so I have an image of that. So there will be a container created out of that image. So what that application does is it on that application data volume is mounted into this directory /my data, and we'll see in YAML how it's mounted. And this code writes to a optxt file to this directory. Correct. Now the second container is Nginx container. It's a, I will be using Nginx image. And on that, the data volume will be mounted on this folder, users share Nginx HTML folder. And if you do not know Nginx, then just FYI for you, that whatever content is here in this folder, users share Nginx HTML folder, you can access that content using the host name / the file name or whatever. This is a default location of the public folders. You can change that if you know Nginx, then there's Nginx configuration file. In that file, you can go and change the default location also. But if you do not change it, then this is the default location, and that's where we'll mount the so because it's the same AMT directory which is mounted on both. It is mounted on this folder on the geocoder application container, and it is mounted on this folder in the Nginx container. So when this application will write, I should be able to access this content on this content will be available on this container and in this folder in Nginx container. Because this this is Nginx container and it's mounted on the public folder, I should be able to access it outside also. And we'll see example of that just to see how it works. So you have these two containers. This part of same pod. Assume this is the same pod. In this pod, there are two containers. So one container is geocoder container created out of the geocoder application. It tries to optxt in the data directory, and it's mounted on the. So this is the same volume. It's mounted in the data directory. Same volume is mounted into this directory. So whatever this container will write in data directory, it is becoming visible into this directory on the other container, Nginx container, and from the outside I can access this content using the Nginx. If you know the Nginx, you can say Nginx host name / the file which I'm writing, because I'll be writing the optxt. So I'll be accessing optxt from the Nginx. So that is what we'll do. So what we'll do now is, so these are, if you want to try it out yourself, you can clone this directory, clone this GitHub repo. I made this public, so you can access this without asking for approval. So let me open this myself. I'll open IntelliJ. All right. So this is the project, let it load. So this is the project, without going into too much details. Basically, what I'm doing is, as per this, this is the class reverse geocoder.java. And if you, there's a flag write to file, this flag, if you write it, turn it to true, then what is going to see the code here? Let me search for this. Control C, Control F, write to file. And if it's write to file, then it's writing to optxt on my data. On my data is where the mount, I will be mounting the host, correct? And you will see some system output and it's written or something, correct? So what we are going to do is we are going to build an image out of this. This thing, I think I already did that. So just before this, I was building an image of this. You see this image getting built. I am in Docker build -t geocoder. -t is the name of the image. So this image got built, and now I will follow this. Okay. So what I'm saying is that when you're done, then you should change this flag to false, because I'll be using this codes else in the further examples also in the coming topics. But let's move on from here. Now what I'm going to do is, so there's a directory emtdir YAML file. So in this YAML file, what we'll be doing is it's a type of pod. If you see, this is type of pod, and this is a metadata. It's a restart policy is never. The reason I'm saying restart policy is never, because this project, it's not a web application. It's a one-time thing. It just runs one time and then it gets done. Right? That's how it is. That's how it works. So container is geocoder. That's the image which I created, and then command. When this container is starting, then this is the command I want to run: java-jar, then run this jar which I'm creating. So since it's a completable command, container will restart after finishing it. But the restart policy is never. So that's why I send, because this is one time thing, right? It's not a REST endpoint which is live all the time, or this is not a a cron job or something. It's a one-time thing which runs and does something, right? And that's it ends. So, and just so that it runs this main method, right? This java-jar command, it runs this main method. And in this main method, I am doing few things, correct? It's writing whatever I'm writing, correct? So, so that's why I set this to never, because if I don't set this to never, it will try to restart again and again, and it will try to run this many times, which I don't want. So image pool policy, already, because I already have this image at geocoder. So I'm saying if not present, if I don't have geocoder image on my local, then you try to get it from the Docker repository. The name is geocoder, of course. The volume mount, and this is what this is the topic we are discussing today. So this is the name of the data, and the mount path is this. Now, if you see this name data, I have given the volumes here. So we start from here. So the volume I have given a name called data, and it's empty dir. It's a specific keyword, empty dir. It's a blank, nothing is there. So I'm using this volume here, and I'm mounting this into the my data thing. So now you see this container. There are two containers. One is a geocoder container with this hyphen image. Second container is hyphen nginx. So in the geocoder container, I'm mounting this on this folder, my data folder. And if you see in the code, I'm writing this to the my data directory only, some optxt. Right? The second volume is the nginx alpine. So what I'm doing in this nginx alpine, this is nginx folder. So the name is the some web server, and the volume mount same data name. I'm mounting on this path, user share nginx HTML, which is a public path. And I have to make this read only false, because by default, when you create a container out of nginx, it's a read only is equal to true. When read only becomes true, there is some other many configuration you have to do to make this data accessible through a to a URL. I didn't want to do that, so I made it as false so that I can access this data using localhost / whatever the path is. And on nginx, container port is 80, and of course the protocol is TCP. Now I'm going to create a so I will follow it from here. I'm going to create a run this YAML file. So let's see this YAML file on this. So cat en, this is the file. So the same thing which I just showed you. So now I'm going to say kubectl create. So I tried to create it, it had run into error. So I fixed that. So it got created. Let's see the pods. Get pod. Okay, it's ready. Second one is not ready because there are two this thing. So we'll see that. So now I have to do this port forwarding also. From localhost 80, it should go to the 80 on the container. So I think I was trying to do that here somewhere. Okay, where was this? Control R port, Control R port forwarding, and this is the port forward, whatever. So this is what I will do. So this is on. Now you will see the below post status as 0 container is stopped after running the command once. So you see it's not ready. One container is ready, which is Nginx. Second container is not ready because when I ran this command in this YAML, when this command got run and it got over and it got run, when it started. So now what I'm going to do is I'm going to say local. So I'm going to I'm going to access this file optxt which got written, because now I have port forwarding. I can access to local 8080, which internally go to 80, and this is the name name of the port, geocoding result fetch, and this is a geocoding result fetch, which means the localhost 8080 will go to 80 of this port, and it should give me the file which I have written. Let's see if we are able to get it or not. So because it's a temp file, I will go to temp folder. It's a wget localhost 8080, then slash, what is the name I had given here? op.txt. op.txt. So I got that op.txt. It's okay. So this is what this. So this is geocode. It's trying to get some data based on address, some based on certain latitude, latitude, and longitude. This is the main method actually. So this is the logic we will go through. This is just getting an address based on latitude and longitude. We have discussed in the past also. So this is how MTDR works. Just an example. So what we have shown in this, what we have discussed so far is, we have one pod which has two containers. One container wrote, the geocode container wrote something, and other container can read. But in this example, we use other container as Nginx. So instead of reading in our example, it was making that output available through a URL to the outside world. So that's what we discussed with EMTDR so far. Now, you can specify the directory of empty directory, medium of empty directory. So you can specify medium. Medium is memory in this case. So you can see the description of this. You can say explain ports, pack volumes, EMTDIR, and it says the medium. You can see the description and size limit, and there's medium also. So what type of storage medium should back this directory? The default is blank, which means the node's default medium must be an empty string or memory. So these are the two things available. You can see more description into this. So into this link, and you can run this command to get all this information. So so this was about the MTDIR. Now what we'll do is we'll discuss about gitrepo as a volume starting point. So gitrepo is MTDIR volume, and I'll tell you how it works. So for it is populated by cloning the Git directory, checking out specific revision when pod is starting up, but before containers are created. So between pod starting up and before containers are available, all these things are happening. But once you once this process, this Git repo is cloned, after pod starting up and before container becomes visible, whatever content of GitHub is there, it is made available. After that, if you're making changes to the GitHub, you're committing something or making more changes into the GitHub, those won't be reflected here. So this is a one-time thing. So there's a couple of limitations. First of all, it's deprecated. Second, it works on public GitHub repos, and it does not work on private. So I did not know it. So initially, I had made in the directory, the geocoder directory will be using this example for using the example of geocoder directory here. So it was private. And I was trying, struggling to figure out why this is not cloning. The Git repo volume is not cloning. Then I went to the documentation of this and realized that this is a limitation. It has to be made public. So when I made it public, then I was able to use that repo. This is an example. So a client, user or replica set creates a pod with GitHub volume. And in the pod, you have container. So container is starting with GitHub repo mounted volume. And this is the GitHub volume. Sorry, second one, my mistake. This is the first. Second, what it does is empty directory is created and the GitHub repo is cloned inside the empty directory. Once it is cloned, the container is started with the GitHub repo mounted, because now it's cloned into that empty directory. It has the content of that GitHub repository. So container will have that information. So this is GitHub repo. It's deprecated now. I don't know. And in the future releases, it will be removed as well. So read the description of this, GitHub repo. So you can say explain pod spec, volumes, and you can see this. GitHub repo is on the Git directory, whatever. It says deprecated. GitHub repo is deprecated to provision a container with Git repo, mount on empty directory, and into an init container that clones the. So you can have this init container thing that clones the repo using Git, then mount the empty directory into the pods container. So init container is the property or configuration given by Kubernetes. You can use that to run your git clone command and mount that onto empty directory yourself instead of using a git repo. That's a recommended way if you want to have a git repo volume which has the git repo content available to you. So we will read through this. Represents a volume that is populated with the contents of a Git repository. Git repository volumes do not support ownership management. Git repo volume supports SL next whatever relabeling or something. Correct? Whatever. So you can, these are some fields provided by Git repo. So what we'll do is we'll run this example. So there's a Git repo volume, YAML file. So it has this pod, metadata, spec. So we'll use the images Nginx only. The volume mounts in the data folder will have this, under this public folder itself on the container 80. So this is data, and this data is, you see this name data, and this data is this volume, which is now Git repo type. And this is the repo which I am given. This is a public repo now. I want a main branch and whatever in the blank directory and all those things, correct? And you can read whatever this means, right? A directory, that a target directory name must not contain whatever, right? So this is what I have given. That directory should be a blank one, correct? So I will run this. So we have the, anyway, port forward. So we have to kill this port forwarding and make it available for the other port which we'll be creating. So now let's see. Let me delete the ports which we already have, so as to not cause confusion. kubectl get pod, kubectl delete / Control C, Control V. So this gets deleted. Let me clear out everything. Clear. And I think this is also deleted. Good. Now, so let's see this Git repo first. Sorry, cat git. Sorry, where am I? Cat git repo. The same thing which I showed you, right? So let me clean this up. Now I'm going to say kubectl create -f git repo. Same thing. So okay, it says is Git repo is deprecated. You get the warning also, but it created this anyway. kubectl get pod. So this pod is running. Now what we are going to see is, what is there inside this pod. So we'll go inside this pod, just just to see. So what we are going to do is, you can run this command yourself, or we'll go inside this. Sorry, kubectl exec-it -v. Okay, now there is -c we are giving web server and -f and such. Why are we giving -c? I will explain you, in a while. But remember, this pod had 2 containers. Now we want to tell which container you want to log into. If the port had only one container, then we didn't want to give anything. But now we have to see -c web server. You see the name web-server. This is the name of the container, and this is the container we want to log into. No, actually, this has only one. This has only one container. My mistake. If you this, then it's optional if you want to give or you do not want to give. If you give, it will work. But let's see if I remove this, then what happens? Because this port has one container, so this should work. This should work. But if your port had two containers, then you while logging into the container, you have to tell the which container name, and that name will be here in the containers dot the name, whatever name you've given the container definition. So now we are logged in. Now what we are going to see is we are going to go into this folder, blank directory. So let's what is there: ls user share nginx html blank directory, and this is what you got it from the GitHub repo. So all those things are appearing here. This is what you will see in the GitHub repo. Now, if you want to get something, because I put this in the in the public folder of the nginx, you can always get it from outside. So I'll get some file from by using the command, and I have to enable the port forwarding. So what I will do is I will say Control-R port forward. I will just change the port name here. And see, port forwarding I'm using just for demo purpose, but in reality you access the URLs using the service object which we have discussed earlier. So if you want to understand, if you want to refresh your memory for the service object, go and read, watch the recording of my previous sessions. So let me get the port name. kubectl get port. This is the port name. So what I'm going to do is this. So port forwarding is happening. So wget localhost 8080. Then this is the path you have to give blank. And I want to get a Docker file because Docker file was here. So I'll say blank. Let me copy this from blank dir. Control-C. Oh, it's already here. Sorry, it's already here. So you see the Docker file is already here now. So cat dockerfile.1, and this is the Docker file you get, correct? This is what I had in the Docker, this geocoding report. Let me delete that because I don't want my workspace to get corrupted. Okay, so this is how your Git repo works. There is a concept called sidecar containers. There are various types, sidecar is a terminology Kubernetes uses. So in this example, in the Git repo context, what is sidecar container? Git sync should not run the same containers as nginx. So sidecar container augments to the main container. And you will see, the sidecar containers concept when you work in Kubernetes, it gets mentioned many times. So basically sidecar is something which there'll be main container, which will be doing the real work, but there'll be sidecar containers which need to do something which for main container to work, right? Maybe we'll see a little bit more about sidecar containers possibly in the subsequent session. So now what third thing is, we'll discuss the nodes file system. So it's a local file system, which, we have been using even in Docker also. So it is not recommended because nodes can crash. The whole idea of the Kubernetes was that, it is fail safe. If your nodes get crash and whatever code was there, if you're using, replica set or deployment type of objects, if your code gets crash, it gets started elsewhere also, in case node crashes. And so these are the advantages of Kubernetes file system. Now we are going against that philosophy if you want to use a node file system, because in case node crashes, then that's it, you're gone. But ports like daemon set needs to access host nodes file system, for example, for load provider. As we discussed in the daemon set recording, that you might want to have daemon sets. Just to refresh your memory, daemon sets are the ports which are by default created on the each pod you create. You can specify the labels also, node labels that create daemon set only on these nodes, for example, SSD type of nodes or something like this. Just to keep this simple, you can assume daemon sets are the port which will get created on every port and every new port which gets created, correct? So you have seen daemon set already. So now what we'll do is for the nodes file system, this is the YAML pod volume or whatever mount YAML. And here main thing is, you will see volumes in the host path. I'm loading my local directory, home directory itself into temp folder on the, I'm defining a volume where it called temp, where my local directory on my node itself will be loaded. So then in the containers, everything else is same. Only thing extra thing I'm saying is volume mounts. And then I'm saying name temp, which is the same name as this. And on the container, this will be loaded under /tmp1 directory. And we'll see that. So let's go to that and create one. So this is different this thing. So let me go there. /. This is in this folder. So what's the file name? Pod volume. So cat pod volume mount. So you can see this, right? It's the same thing. So I'm mounting this temp volume, which is my node's local home directory, my own home directory on my node, and it will be mounted on temp1 folder on the container. Okay. So I'll create this kubectl create -f. What was the file name? Pod volume mount YAML. So it got created. So I can see the ports, kubectl get port. And I should have deleted the gitrepo ports. Let me delete that kubectl delete port / this one. Now I have only one pod left, which I just created. Oh, sorry, what was that? Okay, spelling was wrong. KUBE kubectl. Got deleted. Now I should have one pod left, which is this, which I just created. Now if I describe this pod, then let's see. kubectl describe decribe port / this one. Yes, and you see the volumes. So this is the host path. So this this is the host path which I'm using, and yeah, it does not show where it got mounted. You have to, I think it should show somewhere it is mounted. Okay, let's see. Crap -i temp. So it shows the temp1 somewhere it shows I'm missing that. So this is a temp1 from temp, and this temp is this. And where is the temp1? It should specify. Here. These are mounts. So it is mounting temp, which is read and write both into temp1 folder. Now what is this temp? This temp is defined here under volumes, right? So this is how you see the pod. Now let's log inside the pod and see what happens. So I will log in. So I want to see actually, this volume mounted under tmp1. So what I'm going to do is kubectl execc-it. Sorry, I should remove this. Then -bash and cd tmp1. Yes. See, it is showing all the content of my local. If I go to local, I see here whatever I see here, you see here itself, right? So this is how the local I should come out of it. This is how the local mount works, the host mount works, right? Cool. Now this I have shown. Now we'll talk about important concept called persistent volume, and this is what you will be using. So just pay attention to this. In our existing company also we are using this, but before that let me delete the ports. kubectl get ports, kubectl delete java docker sh, deleted. Now ports available. Cool. So now there are most of the companies are on cloud honestly now, and you must any volume which is used in the production application is cloud volume. Like you must be, if you are on Google or if you are on AWS, we are you might be using elastic block storage, EBS. We use EBS in our project quite extensively. If you're on Google, you might be using GC persistent disk. Or if you have, you have your own NFS, then you might have, this is mostly for on-prem. So you might want to, you mount that MFS. You want to use that MFS basically. Or if you're in Azure, this is Azure blob storage, and this is how the blob storage, details on Kubernetes is. We'll not be covering the, most of this, but I'll give you a sense, why do we need persistence volume? So now, whether you are in your on-premise and you want to use NFS, or you are in a cloud and you want to use a cloud, volume system, whether it is EBS or things like this. As a Kubernetes user, I don't want to deal with that, because generally these volumes are, created by some admins. It depends from company to company. In our company, if you have to create a ABR, generally, admins create it. But in some companies, you might have access to create also. But irrespective of that, for you to use volumes, you should not be, as an application developer, you should not be dealing with, where that volume comes from. It is coming from Google file system or Azure file, or it's coming from AWS EBS. You should not be worrying about it. Ideally, you should get volume somewhere created, and you should be able to use it. So what happens in the companies is the admins, Kubernetes admins, create something called persistence volume, and they are the one responsible for getting the volume, available by connecting to, when they create persistence volume, they in the persistence volume definition, while creating in the persistence volume YAML, so as to say, for example, they create persistence volume out of let's say EBS, AWS EBS, if you're on Amazon, or Azure file if you are on Azure, or Google Google, something similar to Google we discussed, right? So they create that. So now they end up creating a persistence volume. Now you have to use, as an application developer, you have to use that. So only thing I have to do is I have to say persistence volume claim. And when I say claim, I don't have to worry about where that volume is coming from. And we'll see example of this. So I just say persistence volume claim, and whatever persistence volume is made available by the Kubernetes administrators, my claim can take some of the volume of certain size. I have to specify the size and the type, whether it's read only or read write or things like this. So that volume becomes available to me. Now, as an application developer, only thing I'm worried about is the claim, and I get that volume claim. And internally, that volume might have come from Azure or from AWS or from NFS. I don't care as an application developer. So this is the concept behind persistence volume and persistence volume claim. And we'll see example of. We'll read about it now. So decoupling pod from the storage technology. So the developers should not worry about underlying storage technology. Like CPU, developers should be able to ask for storage from Kubernetes. So how it is achieved? So you have this concept called persistence volume and persistence volume claim. Persistence volume is created by admin. It's a wrapper underlying volume technology like EBS or whatever, EBS is on AWS or whatever in other file system on different clouds you might have. You can use, by the way, you can create persistence volume from your NFS also, or from your local file system also. I mean, from the node system also. But generally, it is used to create the persistence volume is to create from NFS or from the cloud, volume systems. The persistence volume claim used by users / application developers to get volumes from the persistence volume. You have to specify minimum size in the access mode. And you create, you get this using YAML. In the YAML, like other objects in Kubernetes, any object you can create in Kubernetes using YAML or command line or REST endpoint. So same thing here. We'll see Kubernetes explain persistence volume spec. Let's see that what that is. kubectl explain. This is there. So you can go through that, right? There are so much documentation about it. I will let you go through this. Basically, here you're seeing access mode, and some of this we'll see. We'll see in the example which I'll show you. So now, what we are going to do is we are going to create a persistent. We are going to act as an administrator first. We are going to create a persistence volume. Since I do not have access to any Amazon or Kubernetes or Google Cloud, I'll be creating I'm an administrator. I'll be creating persistent volume out of the our Kubernetes nodes file system itself. So that's what we'll do. But having said it, I think you should go through this. There's a Kubernetes page here. It describes a lot of things. This is about volumes in the Kubernetes storage volumes, and it has you can empty directory we already discussed. If you want to use Google Cloud, this is what go through this. And if you want to use NFS, go through this. And there is something about AWS also. If you want to use AWS Elastic Flow EBS, go through this. If you want to Azure disk and Azure file, so go through this. If you're on Azure Cloud, Amazon Cloud here, Google Cloud here, so you can go through that documentation yourself. Let's see one let's create local, then we'll go through the AWS example on this link also. So now coming back to where we were here, so slideshow. So this is a file, persistence volume local YAML file which I have created. So what it does is the kind is persistence volume, and this is a name local PV have given, and this is me acting as an administrator. So I have created a capacity of 10 GB, and access modes are this, and we'll discuss a little bit about this later. This is a read write once. The read write once means one. Only one client use this in read write mode. Read only many, rest of the clients can use only in the read mode. So this is how maybe there is some system wide or company wide system running which is populating data here. So only that group which is creating which is populating the data can mount this volume in read write once, and others can only read. This is a use case you'll follow, and you can have read write many also, and anyone should be able to read write. We'll go through these success modes in the coming slides. But in this example, I'm creating a 10 GB volume with these access modes, and persistence volume reclaim policy retain, which means that do not delete after the persistence volume claim is removed. And this is what I was telling about, right? Sometimes when persistence volume claim is removed, the persistence volume should stay on. And we'll discuss persistence volume claim also in the subsequent slide. And this I'm creating from the host, from the nodes host. Generally use it for dev and testing. And this is the path I'm giving. So once I create this, you can get this, kubes, it will get PV, and you can get, this, it shows the, access mode also. And whatever I have shown, reclaim policy, read write once, read only many, and things like this. So it gets created. Now I will create a persistence volume claim. So this is the file I have, persistence volume claim local. In this file, I have the type kind defined as persistence volume claim. And in the persistence volume claim, some name I'm giving, some arbitrary name. And what I'm saying is that in this, I want 1 GB access. Now, if you see, I want this in read write once. And storage class name, I'm leaving blank, and we'll discuss what this storage class means in subsequent section. Now, if you see here in the persistence volume claim, I have not given any reference to persistence volume. All I have said, this is me acting as an application developer. And what I want is I want some volume. And I have not mentioned where that volume is coming from. Only thing which I have mentioned is that I want a volume, and I want volume of 1 GB, and I want it in this access mode. Now, how does Kubernetes figure out that, without referencing, without giving any reference to persistence volume, I'm just claiming the volume? How does Kubernetes attach this claim to volume? We'll discuss, in the coming slide. But for timing, this is how it works. Okay. Now, what I'm going to do is, let's create a persistence volume first. So this is the file persistence volume local. So let's go there and see that file. Cat persistence volume local. This is the file. So I'm creating, this is me as an administrator. So I'm creating some storage on my Kubernetes cluster. I'm creating 10 GB volume for anyone to access. And this is the mode. Only one can read it. Others can, only one can read and write it. Others can only read. And this is the path. Because I'm using local, I don't have cloud access. So I'm using my local for timing. But we'll see example of, on the Kubernetes, page how it works for even AWS EBS also. So let me create this. So kubectl create -f persistence volume local, correct? So I can say kubectl get PV. So this is a volume. You can see 10 GB which I have requested. Read write once, read only many, and retain. We discussed that. Now what I'm going to do is I'm going to create the persistence volume claim also. So kubectl create -f persistence volume claim. So kubectl get PVC. Okay, did that not work? Oh, sorry, I'm sorry. It's what is there in the claim? Sorry, what did I do? Oh, my mistake. I should have created the claim first. I ended up creating the pod which uses that claims. So I should have created the claim first. Let's see. This is where I'm using that claim, the volume which I created, correct? This is the claim name, but I'll come to this later. So let me delete this pod. kubectl get pod, and then kubectl delete. It's 0 because I don't have the claim created. That's why pod is also not ready. So let me delete this. So now what I'm going to do is cat persistence volume claim local.yaml. This is what I'm going to create, persistence volume claim. So let me copy this. kubectl create -f, and now I say kubectl get PVC. So this is the claim. This is my claim, correct? Persistence volume claim, correct? Now what I'm going to do is I'm going to use this claim in a pod. So this is the example. You can see this, how this is what I wanted to show you, how persistence volume claim gets tied to the persistence volume. So I'll read this. This is the snippet I copied from this. So I'll just read it out and then I will explain. So as user creates, I will discuss about dynamic provisioning also in a while. User creates a persistence volume claim with a specific amount of storage requested and with certain access mode. And this is what we did, right? Here we requested 1 GB and with this read write 1 success mode, correct? A control loop in the master. This master is the master node of Kubernetes. Watches for new persistence view claims, and this is what we did. We created a persistence view claim and a loop in the master node, which is running in the master node. It finds, okay, there's a new persistence volume claim now. So what it does is it automatically finds a matching persistence volume. So that job is done by that control loop. We don't have to do anything. And once it finds that persistence volume, then it binds that persistence volume to the claim. We'll come to the dynamic provisioning later. If the I have asked for certain GB and that GB is not available because many users have claimed, let's say administrator created 100 GB and 99 GB is used. Now I ask for 2 GB. So only 1 GB is available, 2 GB is not available. So in that case, what happens? Otherwise, the user will always get at least what they asked for, but the volume may be in excess what was requested. So if I do not get, if I ask for 2 GB and 2 GB is not available, I get an error. But it's possible that I ask for 1 GB and 2 GB is available, I might get 2 GB. That's what it means. Once persistence volume is bound to a persistence volume claim binds are exclusive, regardless of how they are bound. A persistence view claim to the persistence view binding is one-to-one mapping using a claim reference, which is bidirectional. Basically, what it is saying is that you cannot have same persistence volume bound to many claims. So once I have used 2 GB out of 100 GB, then that's it. That 2 GB is only for me, exclusively for me, for that persistence view claim. It will not be allocated to any other claim after that. Claims will remain unbound indefinitely if a matching volume does not exist. So if I don't get whatever I asked for, then they will remain unbound. Claims will be bound as soon as matching volume becomes available. If I ask for 2 GB and 2 GB is not available, then it will just this control loop will keep running, and it will keep running till someone deletes their persistence claim and it becomes free, or they or administrator create new persistence volumes. Then I will get those 2 GB which I asked for. For example, a cluster provision with 50 GB persistence value would not match a claim requesting 100 GB. The persistence value claim can be bound when 100 GB persistence value is added to the cluster. So this is what I just explained. We're asking for 100 GB, but the whole volume itself is 50 GB. You will not get it. But if the administrators create, more persistence volume and made the capacity 100 GB available, then you will get it. This is what I've explained. The persistence view claim triggers volume allocation from existing persistence volumes. More important thing is there can be more than one persistence volume, and we'll see, I think, diagram of that also. Access mode of persistence volume claim should be subset of persistence volume. Now, if you see in our, let me go back and I'll show you the YAML of persistence volume. We have access mode here also. And in the persistence volume claim also, we have access mode. So what it is saying is that the access mode of claim should be a subset of persistence volume. For example, if you asked in the persistence volume, you have created read only, and the persistence view claim, you are asking for read and write, it won't work. You will get an error. So it should be, but if the persistence volume is created with read write, and you're asking only for read or read write, that would work. So what are these access modes? Access modes is read RWO, read write once. So which means you are reading and writing. Only one node can mount for reading and writing. RWX, read write many. Many nodes can mount for reading and writing together. ROX, read only many. Many nodes can mount for only reading. One or many are for nodes, worker nodes, and not for ports. So just keep that in mind. Right? This is not ports, the worker nodes, this relationship. Persistence volume can't belong to a namespace because persistence volume need to be available to the ports which are getting created in different namespaces. So persistence volume themselves won't be available, won't be part of any namespace. But the persistence volume claim, because you are claiming this to be used in certain port or something. So persistence view claim will belong to some namespace. This is how it works. So you have this persistence volume created by administrators. You can create this persistence volume from NFS and this persistence volume from EBA, Amazon EBS, or things like this. So whatever way you create persistence volume, but these persistence volumes are created and made available. Now the users or the process are, creating a persistence volume claim, so they can access any of this persistence volume, whatever is available, and use that in the port. And the same is the case. If you see here, these are not bound by any namespace, but the persistence view claims are inside the namespaces, and these persistence claims are used in the ports. So this again, I'm just repeating how persistence volume claim gets bound to a persistence volume. A control loop in the master watches for the new persistence volume claims, find a matching persistence volume if possible, and binds them together. Since already created volumes are available for persistence view claims, control loop can assign whatever volume is available to persistence view claim. This we already went through this. Now, how do you use this persistence view claim in a pod? This is what we'll do. So I created this YAML file. So this is a type pod, and here I am creating. Remember this claim which I created here. Its name is MySQL PVC persistence claim. Same name will use here. My claim name is MySQL PVC. So here I'm creating a volume, giving a volume configuration, and the name is MySQL data. It's persistence view claim. It's getting from persistence view claim, and from this claim name it will get. Now this MySQL data, I will be using this in the container. I'm creating a MySQL. In MySQL you have to pass this information. And this is needed by environment variables are needed for MySQL, and volume mount is MySQL data, which is this. This name MySQL data is same as this. And this is a mount path. On this mount path, I will be mounting this, correct? And the ports, this is again my SQL container configuration. I have to enable this container port 3306. So what I will do is, I think this is what we have done. Cat persistence volume claim port local port. So let's see this. This is what I have just shown you, MySQL by MySQL, and this is the claim name, and this is MySQL data, which is getting used in the MySQL containers, correct? The container from MySQL image I'm using this volume mode, and this is the MySQL data, which is same as this. So let's create this kubectl create -f. This got created. Let's see the code. Kubectl get code. Oh, why code is not ready? Let's see. Kubectl describe. Did I give the right image name? I think I should have given the right image. Let's see this. CRIB/. It is there. So why it's saying it's not ready? Oh, no, it's running. It was getting ready at that time. So the pod is running. So now what we'll do is let's describe this pod. So kubectl describe this pod, and you can see the all those things. There's a volume which is coming from claim, and there's the claim name, and things like this. Of course, other things are whatever given, the pod, the password and everything. We generally don't give password like this, and we'll see in the subsequent session how to use password or something, right? So yeah, so that's about the describing this. So now what we are going to do is we log into this MySQL and see, go to the MySQL prompt. So let's see this kubectl get pods. So kubectl execc-it MySQL demo pod -bash. Now we are inside the pod, and this is the command which I wanted to run. A root and password is what we have given. So MySQL -user root -p test 123. Okay, is it not correct? 1234. My mistake. 1234. Now we are inside the MySQL. You can run the MySQL commands. You can create database if you want. We create database, database demo db or something. See demo db, whatever you can do in MySQL, you can do all of that, right? So this is one way to create MySQL and use the volumes which you have created inside the MySQL, correct? Okay, one thing which I wanted to show you was, let me exit out of this. In the describe command, so this is the MySQL container pod, this container ID, this the image it got created from, these are ports. So this is one thing you should check. These are ports which are made available. State is running. These are environment variables, and the volume data persistence claim. Okay. I wanted to see where the path is. I think that will be in the persistence with claim. Yeah. Okay. So this is about using that claim in the pod. Now recycling persistence with claim. When the pod is terminated or not crashed, the volume is no longer associated with any pod. Since we mentioned persistence volume reclaim policy is equal to retain, the volume is not deleted, because when you say this retain, that means it will be available even after pod is crashed. So to get the volume back, you can delete the PVC completely, not yourself.